Hi dear students, welcome back to another lesson. Here we are going to discuss the previous year questions from the chapter Electromagnetic Waves. One of the easiest chapter of the grade 12th syllabus it is. Which all our previous year questions came from the last 2 years mainly we are going to discuss in this video lesson. It will help you surely how to face the exam from this chapter and also the concept you might have, then how to present this we are going to deal in this video lesson. So, let's start the discussion. Question number 1. Electromagnetic waves with wavelengths 10 nanometer are called. So here, the first idea is the electromagnetic spectrum you should be thorough with. In many different orders you can do it. Suppose you arrange these electromagnetic waves in the ascending order of wavelength. Then it will be like this way. Gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves and radio waves we have. This is the ascending order of the wavelength. Gamma has the least wavelength and radio waves has the highest wavelength. Normally for gamma rays we have 10 raised to minus 14 to 10 raised to minus 12 meters is the wavelength of gamma rays. Starting from gamma, the wavelength of the radio waves maybe go to 10 raised to 3 meters, around 1 kilometer range. In this range it is going on. So that spectrum should be have clear-cut idea for you to give this answer. Now if you know the wavelength, you could make the concept of frequency also. Because the speed of the EM wave C is equal to nu times lambda. Frequency into wavelength is the speed. So if you know the wavelength, you could find the frequency too. How? Frequency is equal to C by lambda. Just supporting idea I am giving. So here the spectrum should be perfect. Any one ascending or descending order of these waves should be made perfect. Then it will be easy for you to face this type of questions. So here G, X, U, V, I, M, R. Gamma rays, X-rays, ultraviolet, visible light, infrared, microwave and radio wave. This is the ascending order of their wavelength. So gamma have 10 raised to minus 14 to 10 raised to minus 12 meters. Then from there, X-rays have 10 raised to minus 8 meters we can say. Then ultraviolet have till 400 into 10 raised to minus 7 meters can have. Then visible have the shortest length 400 to 700 into that much of nanometers or 4 into 10 raised to minus 7 meters we have. This one to 7 into 10 raised to minus 7 meters. Then infrared we have around 10 raised to minus 3 meters till we have. Then microwave have 10 raised to minus 1 meter, around 10 centimeters we have. Then from 10 raised to minus 1 to radio wave we have 10 raised to 3 meters. Here the question is, the wavelength with wavelength 10 nanometer are. So 10 nanometer will becomes under 10 nanometers, 10 nanometer is equal to 10 into 10 raised to minus 9 meters. That is nothing but 10 raised to minus 8 meters. So 10 raised to minus 8 meters comes under X-rays. So option here, it is X-rays is answer. D is the correct answer for this. Hope you got it. So that spectrum should be at least the approximate range you should be ready. Once more, the gamma rays have wavelengths till 10 raised to minus 12 meters. Then X-rays have 10 raised to minus 8 meters. Then ultraviolet, we can have 400 nanometer till 400 nanometer. So 10 nanometer to 400 nanometer, ultraviolet we have. Visible light, 400 nanometer to 700 nanometer we have. Or we can say 4 into 10 raised to minus 7 to 7 into 10 raised to minus 7 meters. Then from there onwards, infrared have 10 raised to minus 3 meters. That is 1 millimeter till infrared have. Then in centimeter range if you come, it is microwave till 10 centimeters. Then after that above all it comes under radio waves, 10 raised to 3 meters it can be. So keep in mind, let's go for the next question. Which one of the following has the highest frequency is asking. So just previously done the spectrum in ascending order of wavelength, then that is equal to descending order of frequency. So gamma rays have least wavelength but it has the highest frequency. The other end, radio waves have greatest wavelength, then it have the least frequency. So gamma ray, least wavelength, highest frequency, the most energetic radiation we can say. Radio waves, highest wavelength, but the least frequency have. Now, in the options are infrared rays, gamma rays, radio waves, microwaves. So, which has the highest frequency is the question. So, of course, out of this, the best one is the gamma rays has the highest frequency. Then at the other end, radio wave have the least frequency. Then if we compare infrared and microwave, then the order you know, gamma rays, X-rays, ultraviolet, visible, infrared, microwave and radio waves. So as per the frequency if you do it, this is the descending order. So frequency is greatest for gamma rays, least for radio waves, then microwave, then infrared, like this is the ascending order comes. Hope you got it? Let's go for the next question. Electromagnetic waves with frequency 1 into 10 raised to 18 Hertz. 1 into 10 raised to 18 Hertz are known as. So it's a frequency range they are asking for. So if you do this one question, so to go through each wavelength range and frequency range, sometimes you may feel difficulty. So previously I gave you the wavelength range. Then you fix that one. If frequency question comes, the better to calculate the wavelengths. Because you know, all the electromagnetic waves are moving with the same speed. Each one of them have same speed. How much is the speed? C equal to 3 into 10 raised to 8 meter per second is the speed of the electromagnetic waves. So from that one, C equal to nu times lambda we have. So lambda if we calculate it will be C by nu, that is equal to 3 into 10 raised to 8 divided by nu is given here 1 into 10 raised to 18. 1 into 10 raised to 18 it is. So this will be equal to 3 times 10 raised to 18 if you go to minus 18. So that will become minus 10 meters. So the wavelength is 3 into 10 raised to minus 10 meters. 10 raised to minus 10 meters we know that comes for X-rays. So this belongs to X-rays. Option C is the correct answer here. Hope you got it. So if you are able to get the track of the spectrum of both wavelength range as well as frequency range, well and good. If not, fix the wavelength range. It's easy to, I hope. Then from that, if frequency question comes, you convert to wavelength range. Because C by nu will give you the lambda. Then lambda can convert which waves it comes. Hope you got it. Let's go for the next one. A plain electromagnetic wave is traveling in air in plus x direction. So it's moving along positive x direction. At a particular moment, the electric field E is along positive y direction. At that moment, the magnetic field B is along. So regarding magnetic field is a question, electric field is given and propagation of also wave also given. We studied that if E is along positive y direction, then we can write Ey is equal to E0 sine k into the direction of propagation of the wave is positive x direction. So kx minus omega t plus phi. Then B will be equal to B0 sine kx minus omega t plus phi, because both electric and magnetic fields will be in same phase always. Only difference is the peak value of this both and the direction of propagation. So we studied that the electromagnetic wave propagate in a direction perpendicular to both electric and magnetic field. Because direction of propagation will be always vector E cross vector B will be it. The direction of propagation. So it will be perpendicular to both electric and magnetic vectors. Hence, the propagation is along positive x direction and E is along y direction, positive y direction, then of course B will be along z direction and also will be in phase. So the options, let's see. So A, positive z direction and in phase with E. B, z direction and in phase with E. C, positive z direction and out of phase with E. D, z direction and out of phase with E. So suppose this is positive z y direction is given. Positive y direction and it is positive x direction. So positive x means I cap is the direction of propagation of the wave. That's equal to, J cross K. J cross K is equal to I. We know it. So positive J is the direction of electric field vector. Then positive K cross will be the direction of the magnetic field vector along z direction will be. So that will be along positive z direction. So answer is A is the correct answer for this. And will be in phase with E also. So in electromagnetic wave, both electric and magnetic field will be in phase. But the propagation will be perpendicular to both. Hope you got it? Let's go for the next question. The phase difference between electric field E and the magnetic field B in an electromagnetic wave propagation along z-axis is. So propagation is along z-axis, but the question is phase difference between E and B. So just now we got it. The phase difference between E and B will be 0. They will be in phase. So option A is the correct answer. Have you got it? Let's go for the next question. The electromagnetic waves used to purify water are. So we have different uses for each electromagnetic waves. So after the spectrum once you are thorough with, then please do each uses also. So here question is regarding purifying of water. So purifying of water means to kill germs in the water. For that, you might be studying the bottled drinking waters will be written UV treated. So ultraviolet rays are used to kill germs in the purifying water. So ultraviolet is used for that purpose. In these options, let's see, there is infrared rays also given. Can you just casually give what is the uses of infrared rays? Infrared rays can be used for, is called heat waves, can be used in remote controls, It can be these IR radiations is also used for cooking of this barbecue grills and all. We can use it. Then CCTV cameras, the night vision photography, IR rays can be used. So these are the uses of different uses of IR rays. Then we have X-rays here. X-rays, what are they used? Medical diagnosis. If bones are fractured, we use X-rays to get the scanning. In the metal detectors, like to scan the luggages in the airports, we use X-rays. So X-rays have that uses. Then we have gamma rays. Gamma rays in medical we have chemotherapy, in cancer treatment. To kill the cancer cells, we use gamma rays, chemo, we use it. When nuclear studies, we use gamma rays. Actually, gamma rays are produced from nuclear fission or fusion reactions, So gamma rays are used in nuclear studies. Also, this medical purpose, treatment can be used. Now, gamma ray cameras are available, which can use to diagnose the internal organs. Like kidney and all, the internal parts we cannot do with the X-ray scanning machines. There, the gamma ray cameras are used. So for medical diagnosis, as well as medical treatment, gamma rays can be used. Are the different uses. So like that, different other waves also, electromagnetic waves also, you should go through the uses. Important, shows 1 mark, you can score that one. Let's go for the next question. E vector and B vector, electric and B vectors, electric and magnetic field of an electromagnetic wave respectively. The direction of propagation of the wave is along. So a vector A and vector B is given. Then yes, we discussed that the propagation of EM wave is always perpendicular to both electric and magnetic fields. Then it will be E cross B will be the direction of the propagation. So C is the correct answer here. It's a transverse wave. So perpendicular to the propagation. Have I got it? Let's go for the next. The ratio of the magnitudes of the electric field and magnetic field of a plane electromagnetic wave is. So ratio of magnitude of electric field and magnetic field. Electric field and magnetic field in this EM waves are related as E by B is equal to C, the speed of light. C is equal to E by B, or it can be the peak values also equal to E0 by B0 also. So in one equation, if electric field is given and peak value, then you could represent the magnetic field vector. How? By using this equation, C is equal to E0 by B0. And also, this C is represented related to 1 by root of mu naught into epsilon 0 naught. The permeability of free space into permittivity of free space. Electric and magnetic concepts you can mix together. So C is equal to half. This one also a unit. C is equal to. So here, ratio of electric and magnetic fields is equal to C only. So 1 by C is the correct answer. Option C is the correct answer. C. The speed of light. Let's go for the next question. An electromagnetic wave is produced by a charge moving with a constant velocity, moving with a constant speed parallel to magnetic field, moving with an acceleration at rest. You know, if a charge is there, around the charge there will be electric field. If there is varying electric field is there, then magnetic field is also produced. And varying magnetic field produces electric field. So the combined variation of electric and magnetic fields produces the EM waves, the basic theory. So there you might go through it. An accelerated charge can produce EM waves. Because accelerated charges means there will be combined variation of electric and magnetic fields. So charge moving with an acceleration will produce EM waves. That's a basic production of EM waves. So constant velocity, it cannot be. Charge at rest never can be. Only electric field will be there. There is no magnetic field. Constant moving is the means there is no varying electric and magnetic fields. Electric and magnetic fields will be there, but these are not varying. So mutually varying electric and magnetic fields produce this electromagnetic waves. Let's go for the next question. The electromagnetic radiations used to kill germs in water purifiers are called. Okay, the same topic only but different way the question came. So to kill germs means to purify the water. We use which one? The ultraviolet rays. See, the same concepts are there. But in other way the question came. Structure is different, that's only concept is same. Next question. Electromagnetic waves of wavelength of the order of a few meters were first produced and detected in the laboratory by. So, okay, the name of the scientist, it is Jagdish Chandra Bose, J.C. Bose, and then origin scientist it is. He for first few meters range, he was succeeded. Let's go for the next question. The electromagnetic waves used in radar system is, you know, radar. Radar is radio detection and ranging. That is radar. Speed cameras or the aircraft controls, they use this radar. In radar, we make use of microwaves. Microwaves we use for cooking also, microwave ovens, you know, and microwaves can also be used in radars. These are two use of microwaves. Then other cases already we discussed. Infrared waves, we already discussed the uses. Ultraviolet rays, we got it. X-rays also we got it. So radars, we use microwaves. And radio waves, we make use for communication purpose. TV, FM, radio, mobile, and all communication purpose, we make use of this radio waves of different wavelengths. The next question. Name the electromagnetic wave also known as heat waves. Yeah, give me the answer. Just discussed already. Heat waves, which produces heat. Yes, it's nothing but the infrared waves. All the heat objects, hot objects. You know, campfire, you know. During winter season, we make use of getting body heated. We use campfire. So burning this fire, if you stand nearby, we feel heat. That's through infrared rays only. So hot objects emits infrared rays. So infrared is called heat waves it is. So only infrared rays are used in charcoal, cooking for the grills and all, infrared rays are used. Next question, let's go. Which one of the flowing electromagnetic radiation has the least wavelength? So least wavelength is the question. You remember the spectrum? Gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, radio waves. This is the ascending order of their wavelengths or descending order of their frequency. So the least end is gamma, the longest is radio waves. So out of the options, yeah, gamma rays is there. So of course, gamma rays answer is the least end. Then microwaves, visible light, X-rays are there. So gamma is the first answer. Out of these all 7, gamma rays has the least wavelength. Then if you think about the frequency, gamma rays has the highest frequency. Let's go for the next question. Choose the correct option related to wavelengths of the different parts of the electromagnetic spectrum. So same concept is there. You have to arrange them in order of the wavelength. So the spectrum, just we got it. Gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves and radio waves. This is the increasing order of wavelengths. Increasing order of wavelengths. So let's check. Option A. Lambda of X-rays is less than microwaves. Sure. Microwaves less than radio waves. Sure. Less than visible. No. Visible is have a wavelength less than microwaves only. So that's wrong. A is wrong. Option B, you check it. Lambda of the visible is greater than X-rays. Sure. Is greater than radio waves. No. Radio waves is the longest wavelength or the highest wavelength we can say. Radio waves. See, lambda of the radio waves is greater than microwaves. Of course. Is greater than visible. Of course. Is greater than X-rays. So, radio is there. Then micro is there. Then visible is there. Then X-ray is there. So, this is the correct order, of course. So, C can be the answer. Now, check what about D? Lambda of the visible light, of course, is less than microwaves. Sure. And less than radio waves. No, cannot be. So, C is the correct answer here. The order of, this is the descending order of the wavelengths is given there. Radio, micro, visible and X-rays. So, while this question comes, please keep in mind this order. G, X, U, V, I, M, R. The ascending order of the wavelength. Hope you got it. Next question, let's see. Displacement current exits only when? Displacement current concept is actually the basics of electromagnetic waves when it comes. The scientist Maxwell, he put forward the concept of displacement current. We studied the displacement current ID is equal to epsilon 0 into d phi E by dt. Between the plates of a capacitor, there is current available. The conduction current is there, and between the plates, he named it as displacement current because it's not because of moving electrons. It is because of varying electric field. So, if electric field is varying, then in that between the plates, there is displacement current. Options: electric field is changing, magnetic field is changing, electric field is not changing, magnetic field is not changing. The question is, displacement current exists only when the electric field is changing. So, d phi E by dt, rate of change of electric flux into epsilon 0 is the displacement current. Maxwell, scientist Maxwell put forward it. So, you know, the Maxwell and Ampere law can be combined. The B dot dl is equal to mu 0 I was there. That I will be sum of conduction current as well as displacement current. That concept was there. So, displacement current was introduced by the scientist Maxwell. Let's see the next question. The oscillating electric and magnetic fields vectors in an electromagnetic waves are perpendicular to each other and opposite in phase, parallel to each other and opposite in phase, perpendicular to each other and in the same phase, parallel to each other and in the same phase. A similar concept we done. So, electric field and magnetic field vectors will be perpendicular to each other, but they will be in phase. So, option C is the correct answer. If electric field is along X direction, magnetic field will be along Y direction, and the propagation of the electromagnetic wave will be along Z direction. So, mutually perpendicular they are. E cross B, we can say the direction of propagation. Hope you got it. So, electric field and magnetic field should vary perpendicular to each other and they should be in phase too. Then electromagnetic waves are created. The next question is, name the electromagnetic wave also known as heat waves. It's a repeating question, is it? So, different order is given. This is infrared waves only. Next question. Which one of the following electromagnetic radiation has the least wavelength? Again, one other repeating question is coming. So, see, different sets of paper that we've gone through last 2 years, different region-wise questions. So you can see some questions, some topics are repeating again. So take care. These all are very important topics from this chapter. So has the least wavelength, we know, it will be of course, gamma rays only will be the least wavelengths. The next question is, a welder wears special glasses to protect his eyes mostly from the harmful effect of, the welding people, they wear like special goggles. So actually, during the welding, the ultraviolet rays are produced. That's harmful to our eyes. If directly incident on this one, so to protect from ultraviolet, he make use of these goggles. The next question is, electromagnetic waves used as a diagnostic tool in medicine are, for the diagnostics, X-rays, ultraviolet rays, infrared radiation, ultrasonic waves are given. So EM waves they are mentioned. So X-rays is the correct answer for medical diagnosis. I told you gamma rays can also be used for medical diagnosis, as in modern medicine it is used. And this ultrasonic waves, do you familiar about this one? It's not the part of electromagnetic waves. It's a mechanical wave. Sound wave, of frequency very least, they are called infrasonic wave. A frequency of more than 20,000 hertz, called as ultrasonic waves. Is it? That can have medical application. USG, ultrasound sonography. USG is used in medicine, but they are not EM waves, okay? So here answer is X-rays. Ultraviolet, you cannot use for diagnosis. Infrared also, you can't use for diagnosis. So answer is X-rays. So here are the few MCQs what came across in the previous different regions of the CBSE exams. See you in another video lesson.